In our last video, we were looking at changing the number of protons, neutrons, and electrons in an atom and seeing what happens to the atom and what changes occur. This video, we're going to look at just the electrons, and we're trying to see what happens to the stability of the atom. Now, all atoms like to follow this thing called the octet rule. The octet rule means that there's 8 electrons in its outer shell. It's completely content to have only 8 electrons in its outer shell. We're going to take a look at group 1 in our periodic table. Our first element is lithium, and lithium has 3 electrons total, but only 1 in its outer shell. That corresponds with the group number. That 1 electron in its outer shell is called a valence electron. And what a valence electron means is plain and simple, the electrons on the last shell. That's it. It's nothing weird, nothing fancy. So when the atom forms a bond, it looks at that 1 electron in the outer shell and goes, you know what? I can get rid of you, drop down an energy level, and be stable. So it's going to lose that 1 electron. It's easier to lose 1 electron than to try to gain 7 more. And this trend occurs throughout the periodic table. It's always going, which is it easier to do? To lose some or gain some? And you're going to see this as we move across this period. Our next element is in period 2. And that will be beryllium. You'll notice that beryllium has 2 electrons in its outer shell, which means it has a valence electron number of 2. It's easier for it to lose those 2 electrons than it is to try to gain 6. Now we're going to skip over the transitional elements and go to group 13. The transitional elements behave differently than what we're working with in this class, and we'll save that for a higher chemistry class. This is just kind of an intro point. Alright, so if you look at beryllium and its dark blue ring, you'll notice that there's 3 electrons in that outer shell, which means it has 3 valence electrons. Those 3 valence electrons means it's going to lose those 3 instead of trying to attract 5. So it's easier to kick out those 3 electrons, drop down an energy level, and be chemically stable. Alright, so going to group 14. Group 14 is a lot different than the other ones. Group 14 has 4 valence electrons. So it's kind of in the middle. It's not needing to gain 4. It's not needing to lose 4. It needs 4 more either way. So elements in group 14 tend to be really good at forming chemical bonds because they're able to combine with a lot of things. And you'll notice our element for group 14 is carbon. Carbon is the most useful element when it comes to chemistry. It's one of the most useful elements when it comes to life. So we need to understand carbon and how it forms bonds for us to understand all the additional chemistry we have coming up. Alright, next one is group 15. This one is nitrogen, and you'll notice that there are 5 electrons in its outer ring now. So now we have a valence number of 5. Alright, so earlier over here we were talking about how it was easier to lose 3 than to gain 5. Well, in group 15, they're no longer trying to lose the electron. They're trying to steal the electrons now. They're trying to gain them. So this element needs 3 more electrons. Now, if it means that it has to form bonds with a carbon to help get those 3, it will. If it means it's forming bonds with other nitrogens, it will. If it means it needs to come over here and steal from groups 1 through 13, it will. They're going to do what they need to form their bonds. Now, I know I'm talking about gaining and stealing electrons and things like that. It might seem confusing, but when we talk about the type of bonds between ionic and covalent, all this will make sense about the gaining, stealing, and such. All right, our next element is oxygen. You're noticing a trend here. Gone in group 16, we now have 6 valence electrons. All right, 8 minus 6 is 2, so I need to gain 2 electrons. All right, next one. Group 17. Group 17 has how many valence electrons? 7. So if you do 8 minus 7, you got 1. So it has 1 electron that it needs. So it's easier for it to just grab up that 1 electron. Now, this group desperately wants to gain an electron. It's really, really close to its dream goal, which is group 18, which does not form bonds because it has the octet rule of 8 valence electrons. So since it's not trying to gain electrons anymore, they're stable. Group 17 is not stable. They're 1 away. So they're going to steal that electron however they can, which usually means these guys are very volatile. They are very reactive. On the flip side, group 1 is the same way. Group 1 wants to get rid of that electron as quickly as possible so it can become chemically stable like group 18. So it's going to get rid of that electron, which is why we have the alkali metals that explode with water. Now in in period 2, we do not see our typical formulas. We do not normally see lithium fluoride. That's not something we normally see in our everyday lives, but we do see sodium chloride. Sodium is in group 1, chloride is in group 17, and those form natural bonds for table salt. All right, so what are the charges? I just talked about how they're going to give up electrons and steal electrons. Well, now it all comes into play here. So group 1, it's going to get rid of that 1 electron. So it's going to have a +1 charge. That's because it has more protons than electrons. And we talked about this in the last video. So if it gives rid of its electron, it's a positive charge, and it has a special word, cation, because it's going to form a little kitty face because it's going to get rid of its electron. So it's going to be a little cat, meow, with a little plus eyes here. Okay, so our little cation, this little pluses. So it's going to get rid of, it's going to be positive. All right, and then wrong button. All right, so as we take a look here, you're going to notice that we have our positive charge. Now let's move on to our next one, group 2. It's getting rid of those 2 electrons in its outer shell. It's saying goodbye. So it's going to have a +2 charge because it's going to have more protons. And since it's going to have more protons, it's a cation. All right, group 13. It has a +3 charge because it's kicking out those 3 electrons, becoming a proton, becoming a cation. All right, so group 14 here. You notice that I have both plus and minus. Okay, the reason it has both plus and minus chilling here because it can go both ways. If it wants to gain electrons, it's going to be negative. If it's going to get rid of the electrons, it's going to be positive. So depending on what it's matching up with, it's going to either be a positive or a negative. Okay, so now we're going to go into group 15. Group 15 has 5 valence electrons. And as we said a moment ago, and when it has 5 valence electrons, it's like, yeah, no, I want to steal in 3 more. So taking in 3 electrons means it's going to have a negative charge because now there's more electrons than protons. So it's going to be an anion. In group 16, it has 2 minus because it's taking in 2 electrons, so it's an anion. And if you haven't guessed yet, group 17, -1. It's going to bring in one electron, so it's an anion. But group 18 has a 0 for charge. It does not form bonds. It's not going to attract anything, so its charge is 0. It's like, I'm full, leave me alone, go away. And it's not talking to the other elements. Alright, use this information to help you with the next 2 assignments.